Next up, we're talking about conversion factors. Y'all, I think that this topic might be one of the most important ones we cover the entire year. Conversion factors will come up in all other sciences, and it's also actually pretty prominent around us. So, what is a conversion factor? What is the formal definition? Conversion factor. All right. So a conversion factor is a ratio of equivalent values. Y'all are actually familiar with using conversion factors, but less thinking about it scientifically and more thinking about it in terms of real world exchanges. So let's say you have a dollar. You have a dollar. And you go to a vending machine and you try to stick the dollar in, but the vending machine goes, I'm not taking dollar bills right now. I'm only taking quarters. Well, you know that. Oof. There are 4 quarters in a dollar. That is a conversion factor. That $1 equals 4 quarters. You're also familiar with another type of conversion factor for length. So you know that 1 foot has 12 inches. So again, y'all are already familiar with this stuff. We're just gonna apply it more to the science realm now. The whole point of a conversion factor is to convert. So we have our starting units, and we're going to multiply it by our conversion factor. And when we multiply it by the conversion factor, sorry, y'all, throwing markers everywhere. When we multiply it by the conversion factor, we are going to get our desired end units. How does this work mathematically? So this is conceptually what's going on. What about mathematically? And I think that's kind of the scariest sounding part of this whole process, that we're using math, right? But it's actually really darn useful. So what happens is we have our starting unit. And this conversion factor tells us how do we get from the starting unit to the desired unit. So it's a ratio. So we're going to involve fractions here. Remember how in fractions, if there's the same thing in the numerator and the denominator, we can cancel them out, right? So our conversion factor is really just our desired unit over our starting unit and we know that this process, so see we have, this is in a numerator, starting unit, this is in the denominator, starting unit. We can cancel these out and we end up with our desired unit. Let's look at an example. Let's say that we're getting ready for a party and we have 120 soda cans. And I want to know how many 6-packs is this? So we're starting with the unit of the can, the singular can. And what we want our ending unit to be is in terms of 6-packs. I know that 1 6-pack is 6 cans. I can write this right here as a fraction. The way my brain thinks of it is that this equal sign is like the fraction bar between the numerator and the denominator. So I can write this as 1 6-pack has 6 cans, or I can write it flip-flopped, and they mean the exact same thing. So 6 cans are in 1 6-pack. These are equivalent statements. They both mean the same thing, but the important part that I want y'all to notice is that you can write this fraction flip-flopped depending on which unit you want to cancel. Let's look at that. All right, let's look at that. Okay. So I have 120 cans. Remember, this is like saying 120 over an invisible 1, right? So that cans is in our numerator. So I'm going to multiply this by our conversion factor, and I'm going to pick the conversion factor that will cancel out the cans and give me the unit of 6-packs. So if cans is on the numerator, I need it to be in the denominator of my conversion factor to cancel out the unit. So let's look at which of these has cans in the denominator, and it is this one. So 1 6-pack has 6 cans. I'm going to cancel out the cans, and I'm left with a 6-pack. So 120 divided by 6 is, how many is that? 20. There we go. Algebra. 26 packs. This was a much more conceptual example. Let's look at a more scientific example next. So example number 2. Let's say that my dog ran 0.044 kilometers. And I want to know how many meters that is. So first off, I'm going to think, which conversion factor do I need for this? I need the one that relates kilometers to meters. So I know that there are 1,000 meters in 1 kilometer. So y'all, in this case, this is a conversion factor, an equation I will not give you. I need you to know that kilo means 1,000. So 1,000 meters in a kilometer. I can write this in 2 different but equal ways. I can say there are 1,000 meters in 1 kilometer, or that 1 kilometer has 1,000 meters. Again, they mean the exact same thing, It's just that you're going to choose which one to use based on which unit you want to cancel. So I'm working with 0.044 kilometers. And remember from math class, we can say that this is over an imaginary 1. So this, the 0.044, is in the numerator. So I want to multiply it by a conversion factor that has kilometers in the denominator to cancel, and meters up top so that I end with meters. That looks like this conversion factor right here. So there are 1,000 meters in 1 kilometer. When I do the math, so 0.044 times 1,000, I get 44 meters. Let's look at one more example of how we would use this type of conversion in a lab setting. Let's say you have some solid powder, and you measure it out on the balance, the digital balance, so you get its mass. And let's say that you get a mass of 0.0462 grams. Well, this number is kind of a pain to write out every time, and I don't know about y'all, but it's harder for me to imagine what this really looks like. How much of it did I weigh out? So I want to convert this to milligrams. So how many milligrams is this? Again, y'all, this is a prefix, the milli, you need to know it. So milli means 10 to the minus 3, or 0.001. So that means that there are 1,000 milligrams in 1 gram. So again, you can think of this milli as 10 to the minus 3, or conceptually think about it as, this is to the thousandth place, which means that there are 1,000 millis in 1 normal. So 1,000 milligrams in 1 gram. Alrighty. So I started with 0.0462 grams, and I want to multiply it by the conversion factor where grams is in the denominator to cancel out. So I want milligrams up top, grams on the bottom, and I know that there are 1,000 milligrams in 1 gram. So 0.0462 times 1,000 is 46.2 milligrams. There we go. Again, y'all, feeling comfortable with using conversion factors is so super important. If you go on to take other science classes, you are also going to have to use conversion factors. They're just really important in how we're able to go from one unit to the next and to make comparisons.